talk a little bit about get line. So I will, maybe that is okay, that whiteboard or the other one. This one is better. Okay, so for pointers, assume that we have a pointer, just to clarify, P declared to be a pointer to an int. There are two ways to fully define these pointers. At the moment, what we have is just some memory, the memory address, number 2 through 3 as 8. And here we have variable memories associated to P, which says I need memory for an int at this moment. So there are two ways to finally initialize it. One is at static time, which means somewhere I have another integer a which was initialized to 7, and P gets the address of A. So what happens? Everything is known at compile time. This is a static variable. Our pointer knows at compile time what value is pointing to. So in this case, we have this A variable, which got the value 7, and A has an address itself, let's say 20A9. And all it gets, P gets the value 20A9, which from our point of view says our pointer goes there. So this is static type initialization. The second way is to ask for dynamic memory location, right? So the second way is saying P equals new int. And you will see after that we can say dereference P equals 9. Store 9 at that location, or we can just put 9 here. It's the same thing. Now, with this approach, the compiler does not know the address at compile time. This is allocation at running time. Okay? So when we have our P like that, 2083, this is the P we have declared there, then I don't know at compile time where this memory is to be stored. So with new int, the compiler, the system gives us some memory location. The pointer takes that memory location, which is not known at compile time, and then with this we store the value 9. So this is where we have to deallocate memory. So in this case, we have to write delete P. But in this case, we don't have to delete anything. Notice? Okay. So this is one issue you have to be very clear about. And when we talk about row pointers, you will see we will use this with arrays here in this simple situation. So this is one issue. Another issue is about getLine. We have seen that at some stage getLine was used as a method in a class. I don't have space there, so sorry, I have to use this space. And the form of our getLine was this cin.getLine. And here we have a C-type string, and we can pass an integer size, maximum size we accept. So size value. So be aware, with this, we are working with C-type strings, and this size value includes allocation for end of string character. But if we want to work with C++ strings, we use a different form. This is a method we will start talking this week in a class. But if you want to use C++ strings, you have to use this form, getLine, where from file or C or standard input. We work now for scene, standard input, but you can use the same thing for reading from file. Just put the name of the file here, and then you put here C++ string. The second argument is what is a string variable. So if you have C++, you have a string variable, M string, and you plan to get it from the standard input device with the keyboard. All you have to do is getLine scene M string. You don't have to pass anything else. So your M string will be initialized from what is entered by the user. And that can be made of multiple words, everything which is on one line. So this string is read, is storing everything which was entered by the user up to the new line character, which is what happened when the user entered return or entered or something. We will see that we can pass a delimiter. But for the moment, this is enough. We work with new line character. Be aware that getLine associates empty spaces at the beginning, sometimes with end line. Assumes that someone has entered an integer with cin. Cin, and something was stored in an int value. And then we use getLine to read everything else. Combining this can get you into trouble because cin leaves the end of line character in the buffer. And if the user has entered an integer and press enter or return, then that new line character stays in the buffer, and when getLine is called, it sees this end of line character and doesn't store in M string anything. It's empty string. The way to deal with this is after you get this, read a dummy character to get rid of the new line character. Read a character here after your integer to get hold of the new line character and ignore it, and then you can use getLine. But the best advice I can have is either stay with cin and perform all the input using cin, and you can do it, or file in whatever I tell you about cin, and it's valid for input from file. Or use only getLine. Do not combine them because sometimes there are small differences which you can spend a lot of time trying to clarify them. Anyway, these are the two things. So, as we won't use C-type strings from now on, as we will concentrate on using C++ strings, I I want you to get familiar with this deadline. But we will see use of it later on. The last thing, this is a global function. As you can see, it's not invoked on anything. This is not a global function. It's invoked on a variable. We will understand a little bit more starting with today's lecture. Any questions? Right. So, we start talking about this topic which will be used every lecture from now on. And you will see that to use and design classes, we start from structure. That's why your assignment 1 part 1 will help you to move to the object-oriented part. And we will cover today information hiding, visibility modifiers, and what is a class interface. We have seen that when you define a structure, you have no memory allocation, nothing. You are doing a definition here. It's like defining int or defining float. There is no memory allocated to this construction. In C++, you don't need type def for structure. You can just, you will see, use straight away variables of this type. So in this example, we have a data type called employee with 4 fields or data members, 2 strings, 1 integer and 1 float. Something kind of similar to what you have for your students, for example, first name, last name, ID number, and maybe char or type. Maybe. In order to work with such variables, we have to, with such types, we have to start allocating memory. So with this declaration, S is a variable of type employee. It's the first introduction of this in the scope, and this is when the memory is allocated based on our definition of employee. And then we start filling in data with specific values with, of course, member operator, right? And we have seen that after we define our S variable, we can define another variables from S just with this notation. Construct S2 from S. And this works fine. But you have to be aware that what happens here is whatever values we have stored in the S fields are copied, crossed, copied over to S2. Who does this? The system for us, right? So there is a copy of data from these values, first name, last name, IRD, salary, into S2. So S2 ends up with the same data values. So there are things going behind the scene which will come out when we implement types ourselves, and we will see what's going on behind the scene. So this is one object of the courses as well. But to work with those variables, we sometimes have to do and hard code things that ask the computer check first name of my first variable against the first name of the second variable, and if they are equal, I want them to display something identical. If they are not equal, we'll do something else. So this is a little bit tedious. What we would like is, as soon as an employee is defined, to associate information to that employee such that tasks like checking for identical name or identical ID is performed using the type itself. So we want to declare objects or components which know things about themselves. This is important because in this way we can design a type employee, and a group works on the employee type, and another group works on company type. Company, which is a set of employees, a group of employees, and keep tracks of other information, not only about employees. So modularity is good because it can speed up the production. But for this, we have to declare objects and components which come up in our problem to solve. Using just structures is kind of limited functionality because you don't have a set of data from the group who designs the employees to be passed to the group who designs the company, for example. If you work with structures and define various functions to work with those structure variables, you can change it very easily, and those changes are not passed to the other group, and then things get a little bit difficult. But we go again. So we would like to have a typed a tool to represent objects which contain not only values but some functionality. As I said, I would like an employee to know how to print itself. I don't have to go every time when I want to print an employee to go and display first name, last name. This is quite a repetition. So data and operation into a single unit is what object-oriented programming wants to do. And this is done with the class concept. And put it very simply, a class concept is based on a structure where on top of data we have functions included. And those data members are called variables of the class. Data members, you will see in Java they are called instance variables, but something else is called instance variables. And the functions in the structure are called member functions in C++ environment, or methods. Methods is coming from Java, and it was adopted by C++ community. So let's consider this simple setup. We want a program to deal with geometrical shapes. Mathematics is a little bit more easy to handle because it's a little bit more structured than natural occurring objects. Assuming this, we want to deal with shapes. We don't want to perform very complex tasks. We just want to be able to, for example, in the long run, find the area of all shapes. We want to do, let's say, architecture, or someone who does carpeting wants to know total area needed for something. And for this problem, we have to abstract away, because in computers science, probably you know, in programming, you always work with abstraction. We don't really have a real circle, because we are not interested in the color of the filling or the color of the outline. When you work with graphical objects, then you are interested in this, right? But for our problem, those colors are not important. Where you draw the circle on the screen is not important. So we abstract away, which means we ignore details which are not important for our problem. This is the abstraction process. And for our problem, we will consider that a circle is defined by the center, not really necessary, but to make it a little bit more interesting, and the radius. The radius is needed in order to compute the area of a circle. So this is the main goal of our problem, to calculate the area. In this situation, what we have to do is have our data values. X is a horizontal coordinate, Y is a vertical coordinate, and we choose them to be double. They can be integers, but for the simplicity here, we chose them to be double. And the radius, which is normally a real value, right? This is considered to be double. All we do, we compute the area based on the mathematical formula, radius squared times pi. Pi was defined previously somewhere where we'll run the program. Notice that this class, if I don't put it here, can be called structure. In C++, you can put structure here. The name, I choose it to use capital letters. And we list here data and functions. And then we put the closing of our construction. Now, in this example, we use class keyword instead of structure. And we put here the public visibility modifier. When you design classes, you will see that you can have public area, which is available to everyone who includes the file where this is defined, and private. Private part is not available to everyone. Private part is available only to the class itself, class members, and friends, but friends will be talked about later on. So, because we want, what does it mean outside word? After we define this, we want to use variables of circle type in main, for example. Main is outside word, and there is this jargon. This is the type, and then we have clients for our type. So clients of our types are outside word. After we define this, we can work with object of our type. C is a circle, and then we assign values like we did for structures. But now when we need the area, we just invoke that method. So our circles know their area. And we say we send a message to the circle object to give us its area. Right? So this is the new addition. The fact that we will see bits and pieces. Now, the data members are here because they are public in our definition. If everything here is in the main function, it's outside word. Whatever was public is available to the outside word. And we will see that we put, for our example, main inside the same file. But this approach is not the best one because of two reasons, let's say. One, people can do mistakes, change some definition of our circle. Instead of double X, they can say, I don't know, integer X. And then area doesn't work any longer because it's returning some double value maybe, or some other, in this case is not so important, but if we give access to data members of the class to outside world, someone can do mistakes, put a pointer to double, and then everything is messed up in whatever facilities we have put there. So one reason is safety issues. If someone by mistake changes something in how you define your data members, things can go wrong for behavior. And second, we want to be able to extend, to add functionality to this without the user changing their code. If possible, code which was written based on the previous type should work with no changes. But if the user wants to use the new functionality, they should be able to use it. So this type of extendability without breaking the code written already based on the previous class definition is one big issue. So classes have to support information hiding. What is important and shouldn't be changed by mistake should be hidden from the user. This is metaphorically speaking, because everyone in the end will find maybe somehow what the data member are. But by information hiding, we mean that not everyone can change directly data members. This is what is information hiding. It's like a contract between the programmers and the user. The programmer says, I give you these methods. You should use only these methods. You don't have to worry about data members or what is hidden. What is hidden, I can change it any time. But I will give you the same methods with the same prototypes, and you can work with those. So information hiding limit access in principle to method and member in a class which are not of interest to the users, but they are needed for housekeeping. So this split the information in what is available to outside world and what is not available. Extremely useful feature. Security issues somehow are related to this hiding. Inner workings of a class should be hidden. You don't know how the string is implemented. You know the string C++ string. You know that you can use size, you can use index operator, print strings, but you don't know whether your string is made of an array of characters, a pointer to an array, and some other construction. Maybe a pointer to bytes. You don't know, and you don't care. And the designer of the library can change data member. So in C++ and in Java, this information hiding is done with visibility modifiers. That public, you have seen, and private keywords. There is a third one in both languages protected, but this comes when we talk about inheritance after the term test. Public members and methods can be accessed from outside world, and of course from inside as well. Private members and methods can only be accessed by the methods of the class and by the other members of the class. So Now, if we go back to our simple example, circle, it's a good approach to make most of your data members private. This is where you can do improvements and changes in particular. In this case, we have our x, y coordinates and radius private. In other words, we can't access them outside the class itself at the moment. You will see. All access to this is done through well-controlled methods. So the method of the class, where you can put checks, is this value r, for example, positive, you can put check. A radius can be a meaningful radius only if it's positive value. If it's negative, it can get garbage, right? So with this approach, we can say, oh, if r is not positive, display something and let the user that that value is not good. But the problem is, who does this displaying? It's another issue, the class itself or the client. We will talk later about this. But for the moment, be aware, we can set these values in a controlled way through the method of the class. For the moment, we talk about how to initialize data members. We will see a better way, object-oriented way later on, and how to compute area. And as you can see, our init method, which will do assigning values to our circle objects data members, use its parameters to initialize this. And based on those values, notice that this m radius, which is a data member, private data member in the class, is available to right. It's straight away available to everything in the class, right? Okay, so hiding information. We say that we hide this part from the user, and the user, in order to use our type, will need access only to these functions and not even their implementation. They need access just to the function prototype to know how to invoke those functions. Like we have seen here, we don't know how getLine works for whatever type we have here, CE. But we know that it gets two parameters and we have to invoke it on an input stream type. So now we can work with our circle. As you can see, it knows how to initialize itself with this function, behavior, and it knows how to display what its area is. And in this way, circle is a unit, a black box somehow, which communicates with the outside world only through its public part. And this unit needs good design. And it's called encapsulation. Sometimes you will see that information hiding and encapsulation are interchangeable. There is no real distinction between encapsulation and information hiding, because when you put together some data types, abstract data types, you have to have protection against around information which is essential for your types to work it properly. The data associated to a circle, those x, y, and the radius, are hidden from the user. They don't have direct access, right? So, advantages: the inner working is not known to outside the class and can be changed at any time by the user, by the designer of the program, like designer of the type, and release a new library version, and then we have fun with updating applications and stuff like that. So the program cannot accidentally change a data variable to an incorrect value, which will make your type useless. So the public method are providing what is called the interface of the class, the public method. We know from the string the interface when we read information, and for other types provided by the library. So that public part will be available, public interface in some form, it will be available to the user. Now we will see that as long as the interface doesn't change, we can fiddle with the implementation as we like. So in this simple example, but you can extrapolate to other things, we change the circle. Instead of using radius, we have the third data member diameter. But for more complex things, assume that you have a type string which uses here an array of characters, array with set size. And then later on, the designer of the type said, oh, but it's much more efficient to use pointer to characters. And they can change and do other things, other type of changes, use a vector of bytes or something else. As long as the interface stays the same, notice we have 3 values here for the initialize method, and we have no argument for the area. So from the user's perspective, the interface is the same. Whatever program was written with a previous circle variable will work. What is changed is how we implement this, but these methods, in most cases, you will see, are not available. The method implementation are not available to the user. They have only the prototype of the method, public method. Right, so with a new definition, the circle does its job the same way, even if it has more changes. So, with this object-oriented approach, programs are more flexible. You can change things, you can add, I don't know, some method in the private part to perform some of the tasks of your type and make the class better somehow. As long as the interface stays unchanged, things are okay, because you have to be aware that people use code design with a interface, whatever that was. So if we look at the string definition, explanation from C++, as you can see, all they have here are member types, not member data. Because these member types come up when you use the functions. And then all you have access to is member functions. public member function. Public member, it means we can use this. We will look at this later on. String assignment, public member function. Because it's a public, we can use it. As you can see, only public members are provided by this is not a library provider, but it's what you will have available even if you use the library file. Element access, everything is public. As you can see, at and operator index, they are both public members. That's why we have access as long as we include the string header file and use whatever. A lot of strings here, as you can see. Non-member function, and here is getLine. Non-member function, it's a global function, I mentioned it there, and you can have information if you get in trouble. We will see concatenate plus operator, it's not a member function. We will talk about those things. The last thing which is interesting, notice a string is a type def, is something which is defined with whatever we will talk, last part, templates. When you work with strings, sometimes you get some warning saying, if you use for integer I equals 0, I less than string dot size, you invoke the size method. Now the size method is of this type, size t, which if you click on it, in fact is unsigned integral type. So you have two options to get rid of the warning. Instead of saying for int equals 0, I less than string dot size, you say int I equals unsigned 0, I less than string size, and then you will see the warning gets away. Or you can use size t. You can say size t I equals 0, I less than size strings dot size, which is fine. As you can see, this size t is used to represent sizes and counts. Sizes and counts. So when you go through a for loop, you can have this thing. It's included in C standard definition, C standard library, C string, C time, and part of, I think it's part of string type as well. So, this is what we have to do. It's a brief, slow introduction to what we have used for classes. Okay, this was the thing, and now I have put together here that program I mentioned and how we have it lay out. And I put some to-do stuff because normally it's boring. To read just code, you might think, oh, I understand. Until you work with it, be aware you might not understood it properly. So, as you can see here, we have the circle. In terms of notation, you can use X, Y radius, but then if you use X, Y, R, even if you have capital letters here and small letters there, it can be confusing for you. Some people use underscore X, underscore Y, underscore radius. This is discouraged because some library functions, some library tools use this type of notation for their variables, underscore. Some other people say X underscore, Y underscore. You can get confused quite easily with that underscore. Another approach, but there are critics against this as well, is to use M from my X, my Y, my. Now, for classes, as a rule, we use type starting with capital letters. If I have circle or a rectangle or a student or employee, S capital, A, E capital, and so on. If we have more words, string with allocation, each word starts with capital letter. Right. This helps to read the code. Everything which is part of the class, method, or data starts with lowercase letters. So when I read something like C area, I know it's a method, not a global function. It's a method because it's invoked on an object. Right, now we have data members and the two functions we have seen. Normally you have this type. You notice I have a constant definition for pi. Put it there and is used here. We will talk about this. Normally the user of the class gets only something related to this, the header file. You will see the header file contains the class declaration. The class implementation, this part is put in CPP file. So this is not directly available to the user. Therefore, the user of the class, but in this case we have everything in the same program. The user of the class has, if we have it in a different file, to include that file and so on and so forth. When we have it everything in the file, in the same file, we don't need any including. But once again, this is the client of our type. It's outside Word. We are not allowed to directly access this. So when we use our type, we use it through the public interface. Init and area are the public. We will see that in order to do this kind of implementation outside the class, we have to use a syntax. But this is a topic of tomorrow's lecture. So, now, if you run this program, it gives you just the area 78.53, whatever. If you want to use straight, change c.mx to a different value, like 5. Notice you are not allowed, and you get here, good explanation, error double is private, not available here. So in order to change it, we will see, we provide method ourselves, or we can say, we invoke this function again, with changing data, put the 3, this won't change the output, you see, but we can change this to 1 and get what is the area in this case, 3.14, because radius is 1. So as you can see, this is a very minimal class. We have to provide tools around this, and this is a topic of next 4 weeks. Right, thank you very much. So this is all for today. We will continue tomorrow. I have office hours today. If you need clarifications, discussions, please.